Hello everyone and welcome back. I'm Miss Aker and we are ready for some math thinking today. Let's get started with Just Know It. Remember, that's the part where we know it just like that. And today we're going to continue some of the work we did last week, and we are going to practice adding fractions with common denominators. So the first one here, look at those numerators. Next one. All right, think fast. Next one. And last one isn't addition, it's subtraction. I think you can do it. Okay, let's check your work. How'd you do with the Just Know It? 1/2 plus 2/2 equals 3/2. Nice job. Remember, you just add those numerators, the denominators stay the same. 4/10 plus 2/10. 6/10. Nice job. And the next one, 1/3 plus 1/3. Those are both unit fractions. And yeah, if you said 2/3, you got it. And this next one, 2/4 plus 1/4, 3/4. And last one, little challenge here, some subtraction. 4/4 minus 1/4, 3/4. So we're taking one piece from the whole, one part. Nice work. Let's move on to figure it out. For figure it out, we have a word problem here, and we're going to use those 4 steps that we use for every word problem. Do you remember them? Read, think, draw, write. By following those steps when we work on word problems, it'll really help us make sure that we're showing our thinking and solving what the problem is wanting us to solve. So let's take a look at this one. King's tablet was fully charged in the morning. Then he used 2/10 playing games like kids do, 4/10 reading books, good job King, and 3/10 doing homework. What fraction of the charge remains on King's tablet? Look, there's a picture of the tablet right there. Okay, so let's get our RTDW. So you're figuring this out at home. What could we do to make sure that we're solving for what the question is asking? It wants to know how much charge remains. Okay, so that means it's going to be something that's left over once we use the 2/10 for the games and the 4/10 for the books and then the 3/10 for homework. So I'm remembering last week when we were working on our figure it out and we were kind of using a number bond to decompose. And so let's decompose and let's see, if 10 is the denominator, that must mean the whole is 10/10. Okay, and we have 2/10 here, 4/10, and 3/10. So I have my number bond here, and I used all of that up, so I need to know how much is remaining. You know what, I'm looking at this and I'm thinking, well, that wasn't a very good model. So when we draw a model and it doesn't really help us, then what we should do is stop and try something new. I think I want to do fraction strips instead, or maybe a bar model. Let's think about it together. What would you use? Okay, let's try that bar model. So let's make our 10. So let's do 4 lines, because that'll make 5 parts. 1, 2, 3, 4. And then if we cut that in half, that'll give us 10 parts. And so we know each of these parts is 1/10. So if King had used 2/10 playing games, so let's shade that. 4/10 reading books, 1, 2, 3, 4, and 3/10 doing homework, 1, 2, 3. How much charge is left over? I'm noticing that there's one part of our whole that's not shaded. So that must mean that he has 1/10 of the charge remaining. So we read it, we thought about it, we drew 2 models. Our first model didn't really make sense, so we drew a second model. Now let's write an equation to help us show our thinking. So first we added together 2/10 plus 4/10 plus 3/10, and we got 9/10. And we know that 10/10 minus 9/10 equals 1/10. And we know that because we proved it right there. Great job with the figure it out today. We just practiced a problem that used subtraction, or figuring out what was left over. And so today, for our what's new, we're going to actually use the same learning target as last week, but instead of practicing addition, we're going to focus on subtraction. So if you'll remember, our learning target was, I can use models to add and subtract fractions. And we reminded ourselves that models are different drawings we can do, like using a number line, or an area or bar model, or fraction strips, or a number bond like we tried out but didn't work so well for us. To add, which is me putting them together, and subtract, which means finding the difference or taking away fractions, the numerator and denominator. You know, the Frankie fraction song that helped us remember what each of those means. So today, when we're working on our what's new word problems, we're going to keep thinking about what is the problem asking and how it shows us if we should add or subtract or do some combination. So grab that piece of paper and a writing tool so you can get started with me on what's new. I see we have a word problem here, so I'm going to start by writing out my steps. R, T, D, W. Read, think, draw, write. Let's read it. Atticus is planting a garden for the spring. 2/8 of the garden will be tulips. What fraction is left to grow other flowers? Okay, I think that it's pretty important to know that there's 2/8 of the garden is tulips. That's that flower. And I think we're going to be solving for what's left. It says what's left to grow. So 2/8 is already taken up, and what's left? So I think I would like to draw a model. And to me, I want to start with an equation too. So if 2/8 is the part we know, we can see that the denominator is eighths. So in 8 parts. So we know the whole of that garden would be 8/8 because that equals 1 whole. So if I wanted to write an equation, I would write 8/8, that's the whole garden, minus 2/8 of the garden, which is going to be tulips, equals some number. Okay, so that's going to be some fraction that's left over. So I can do this, I could do it just like that. I can just take 2/8 from 8/8 by subtracting the numerators. So I could see that that would equal 6/8. But you know what? I want to prove it. So I want to make sure I show that what I solved for in my head is also true with my model. So I'm going to make sure I draw that model. So I'm fond of the bar models. I'm going to draw 4 parts. So I need 3 lines. And then I'm going to put that in half. So that gives me 1/8, 1/8, 1/8. And I can show my thinking about this. 1/8, 1/8, whoops, 1/8, 1/8. And if I have the whole, that's the whole garden, and 2/8 are going to be tulips. So how much is left to be other things? Well, this is 3/8 and 3/8, so that equals 6/8. I have proven what I solved for my equation by using this model. Now I'm going to write a sentence. What fraction is left to grow other flowers? 6/8 is left for other flowers. We got it. Here's another one. Let's go through our steps. R, T, D, W. Jaden shared his bag of chips with his cousins. That's nice of him. He gave 2/8 to Henry and 3/8 to Josiah. What fraction of the bag does he have left to eat? Okay, so again, I'm seeing this eighths. So again, this is another word problem that has eighths as its whole, so 8 parts. So we know we're going to have 8/8 equals the entire bag of chips. So it's like he's dividing it into 8 parts. He gave 2/8 to Henry. So 2/8 is for Henry. And he gave 3/8 to Josiah. So 3/8 equals J, I'll put J, Josiah like that, JS. Okay, so we're thinking about it. We want to know what's left for Jaden. What does he get to have? So if this is the whole and these are the parts that he's giving away, we need to take away these parts from the whole. Now we could do this a couple ways. We could first take away Henry's from the whole, and then what's ever left, we could take away Josiah's. Or what if we use what we did last week and we put these together first? So let's do that. We're going to add up the parts that he's taking or he's giving away. And I know I'm going to add the numerator, so I get 5/8 because it's still the same number of parts. Okay, so he's giving away 5/8. So now I can write a second equation. 8/8 minus 5/8 equals, and I'm going to use a letter here. I'm going to use C for chips. And I better write that somewhere so people know that C equals chips for Jaden. That way, if someone's looking at this, they know that the letter I used, what that means. Okay, let's draw a model. What if we draw fraction strips? So if we start with the whole, here's our one whole bag of chips. And we have 1/8, 1/8, 1/8, 1/8, and 1/8. So that's the 5/8 he's going to give away. And we need to know how many are left. So if we have 6, 7, 8, looks like these 3 are left. And if I check my work over here, 8/8 minus 5/8, C equals 3/8. I proved my solving in the equation. Now I can write a sentence to help me show. And my work is kind of a little bit messy, but that's okay because I'm showing all the different things that my brain is going through while I solve. And I'm just going to write a small sentence here. So there are 3/8 of, the bag left for Jaden. I hope Jaden enjoys those chips. It's one of my favorite parts of our time together where you at home get to try it out and share with us on social media, or you can let me know. Some of my students have let me know that they've tried some of these problems at home. So here are some try it problems for you. So we have 2 bare number problems, and they both have common denominators, but these expressions say 4/5 minus 2/5. So you're going to be solving for the difference of that. And then 8/6 minus 2/6. So you're going to be solving for the difference of that one. See what you come up with. And what about this word problem? Let's see. So Angel ran 2/5 of a race. What fraction of the race does Angel have left? You guys love running and playing outside. And if you ever run a race, you want to know how far you have to go. Well, she has ran 2/5. Could you use subtraction? Or maybe you could use addition to solve for how much she has left to go. Remember, using a model can always help you figure out and show your thinking. And that is really helpful. Even if you think you know it, it's nice to prove it. So, as usual, we've come to the end of our time together, and I want to do a pattern. So we've learned 3 different high fives. Well, one's a call and response, but let's put them together. So let's start with firework high five, roller coaster high five, and then cool. Are you ready? Firework, roller coaster, cool. All in a row. Here we go. Ready, set, go. Shh. Roller coaster. Clickety, clackety, clickety, clackety, clickety, clackety, wee, wee, wee. Cool? Way cool. Had so much fun with you today.